is also a problem of JEE 2012. For every integer n, let an and bn be real numbers and let f be a function given by fx is equal to an plus sine pi by x for this interval and fx is equal to bn plus cos pi by x for this interval. Notice that this interval is a closed interval, whereas this one is an open interval, and this is for all integers n. If this function is continuous, then what are the possible values of relation between an and bn? This question is basically saying that this function is a continuous function, and this function has been defined in two different ways. For an interval starting with a say even, like say 6 to 7 or something like say 8 to 9, for those kind of intervals, this is the formula for the function an plus sine pi x. Those intervals starting from odd, that is for say 5 to 6 or say 3 to 4 or 7 to 8, this is the formula. Now if this function has to be continuous and it is continuous at all values of x, then it has to be continuous at here also, that is at for 2n also, it has to be continuous here also, it has to be continuous here also, that is at all the end points. Of course, within these two end points, that is within 2n and 2n plus 1, this is very simple, an plus sine pi x. Sine pi x is continuous, similarly cos pi x is continuous. So between these two end points, that is here, there is nothing to verify or nothing, we won't get any information. Similarly between these two end points. But at the end points, that is 2n, 2n plus 1 or 2n minus 1, if we equate the value of the left hand limit and the right hand limit, because suppose I have to find limit x tending to 2n fx, then first of all I have to find limit x tending to 2n plus meaning the right hand limit. If I have to find right hand limit, then I will have to approach x from this side. If I approach x from this side, then I will have to use this formula, that is an plus sine pi x. So what I will get, limit x tends to 2n plus fx will be an plus sine 2 pi. What is sine 2 pi? Sine 2 pi is 0, so an plus 0. Okay. Similarly, what will be the value of limit as x approaches from left side, that is x 2n minus fx. That is if I approach from the left side, I will have to use this one, bn plus cos pi x. What is bn plus cos pi? It will become bn plus, and what is cos 2n pi? Cos 2n pi is 1. So this will be bn plus 1. Now it has been given that this function is continuous. So if this function is continuous, then right hand limit and left hand limit both have to be equal, and also they have to be equal to the value of function at 2n. So if this function has to be continuous at x is equal to 2n, then these two limits have to be equal. So I can say an is equal to bn plus 1. So B is the correct option. Now this is one of the correct option. There are another correct option also we will get if we apply the same criteria of continuity at say this 2n plus 1 at this point. So when we apply the criteria of continuity at this point, so what will happen, that is limit x tends to 2n plus 1. Now if we have to find the right hand limit of this fx, then what I will get, because you see if I am approaching from right hand side, then this is 2n plus 1 to 2n plus 2 interval, this is the odd interval, so I will use this formula. So what I will get, I will get b of, instead of n I have to write here, instead of n I have to write here n plus 1, because I have gone in this 2n plus 1 term, because this formula has been given for 2n minus 1, but instead of finding the value at 2n minus 1, I have to find value at 2n plus 1. So in place of n I will take n plus 1. So this will become bn plus 1 plus cos of n plus this cos of pi x. What is x? X is 2n plus 1. This will be bn plus 1 plus cos pi 2n plus 1. So this will become bn plus 1 minus 1, because cos 2n pi plus pi, that is cos pi, is minus 1. I will explain why I have taken here n plus 1. You see, in this formula bn plus cos pi x, this is given when your interval is from 2n minus 1 to 2n. What I am doing here is I am finding the right hand limit and the left hand limit at this point 2n plus 1. So if I have to find the value of function at 2n plus 1, instead of n, I will have to go n plus 1, because the moment you substitute instead of n plus 1 in this thing, you will get 2n plus 1 minus 1. This is 2n plus 1. So basically I have increased my index by 1. So once I increase my index by 1, I will move from this 2n minus 1 to this 2n plus 1. Okay, so this is the right hand limit at this point 2n plus 1. Now that we have found the right hand limit at 2n plus 1, it is bn plus 1 minus 1. So let's find the left hand limit at this value, that is limit x tends to 2n plus 1 minus, this minus means I am finding the left hand limit. So when I have to find the left hand limit, that is I will approach the function, or that is I will approach x from the left hand side. I will use this an plus sine pi x. So I will get an plus sine pi, and instead of x I will write n is equal to an, because sine n pi is equal to 0. So I will get an. Some of you might be wondering why in this formula I have used n plus 1, whereas in this I am using n. This is because you see the formula for this function fx has been given for 2n minus 1 2n, and then this is bn. I have to find the right hand limit, so I have to operate in this interval, that is 2n plus 1 to this thing 2n plus 2. So basically I have to increase my index of n, that is n, from n to n plus 1, because the moment I increase n to n plus 1, this 2n minus 1 will become 2 into n plus 1 minus 1, that is 2n plus 1. So moment I increase my value, say from n to n plus 1, I will go from this 2n minus 1 to 2n plus 1. Therefore for finding the right hand limit, I have taken bn plus 1 plus cos pi 2n plus 1. This is equal to bn plus 1 minus 1. But for finding the left hand limit, that is this limit, I have to operate in this interval, that is 2n to 2n plus 1. This formula, it has already been given, that is for 2n to 2n plus 1, the value of function is an plus sine pi x. So I write an plus sine pi n, that is equal to an. If the function has to be continuous at this point, these two limits have to be equal. So you can write an is equal to bn plus 1 minus 1. I can decrease the index by 1. So instead of n, I can take n minus 1. So what will happen then? Once I decrease the index from n to n minus 1, the same thing I can write as an minus 1 is equal to bn minus 1. So D is the correct answer. You bring B on this side, so D is the correct option. So in this question, B and D are the correct option.